A wave travels 5,000 miles across open ocean without losing its shape. Then it hits shallow water and collapses in seconds. What changed? The answer isn't what most people think. We imagine waves as walls of water rushing toward shore, like the ocean's pushing something at us. But the water itself isn't actually moving forward. Not really. What's traveling is energy. The water particles are just bobbing up and down, passing that energy along like a crowd doing the wave at a stadium. Out in the deep ocean, you can feel this. A ship rides over a swell without moving much horizontally. The water lifts it up, passes beneath, and drops it back down. The wave keeps going. The ship stays mostly in place. This is the key to understanding everything that happens next. So if the water isn't moving forward, what is? It's the waveform, the shape itself. Think of it like a ripple spreading outward on a pond. The ripple travels. The water doesn't travel with it. But here's where it gets interesting. That only works perfectly in deep water where the seafloor is far below. What counts as deep? Roughly, it's anywhere the water depth is more than half the wavelength. If a wave is 100 feet from crest to crest, deep water is anything deeper than 50 feet. In the middle of the Pacific, that's nearly everything. The seafloor is miles down. But as that swell approaches the coast, the water gets shallower. Gradually, and then suddenly the seafloor is no longer irrelevant. The bottom is there. It's in the way. This is where the physics changes completely. When a wave enters water shallower than half its wavelength, friction with the seafloor starts to slow it down. But here's the thing, only the bottom of the wave is slowing. The top keeps moving at its original speed. The wave is being compressed vertically. It gets taller, much taller. Imagine pushing a piece of string across a table at constant speed. Now imagine the table suddenly gets sticky near the edge. The back of the string slows down. The front doesn't. The string bunches up. It gets taller. That's a wave entering shallow water. As the water gets shallower, this gets worse. The wave keeps getting taller and steeper. But water can only be so steep before something has to give. There's a limit. When the wave face exceeds about 1.3 times the wavelength in height, the geometry breaks down. The top of the wave is moving faster than the bottom. Gravity can't hold the face together anymore. The crest tumbles forward. It breaks. This is what we see on the beach, the white water, the foam, the crash. But here's where it gets surprising. Not all waves break. Some don't. Have you ever seen a swell roll in and just glide up the beach? The water rises, retreats, and the wave never actually breaks. This happens when the seafloor slopes very gradually. The wave slows down so gradually that it never gets steep enough to break. It just gets taller and taller as it approaches shore, then rises up and slides back. It's almost gentle. Compare that to a steep drop-off where the seafloor falls away fast. There, a wave barely has time to adjust. It slams into the shallows and breaks violently. Same wave, same ocean, completely different outcome. The seafloor decides. There's also the angle of approach. A wave hitting a beach head-on breaks differently than one coming in at an angle. The shallow part hits friction first and slows down. The deeper part keeps moving. The wave bends. It peels. This is why some beaches have perfect, long, rideable waves and others have choppy, close-together breaks. The seafloor topography is literally sculpting the wave as it arrives. You're not fighting the ocean. You're reading what the ground beneath it is telling you. Wind also matters. Strong onshore wind can keep a wave standing up longer, delaying the break. Offshore wind does the opposite. It can actually peel the wave face back, making it break sooner and harder. So we return to our original question. That wave traveling 5,000 miles across open ocean, why does it collapse the moment it hits shallow water? Because the seafloor forces a choice. The wave can't keep its shape. It either breaks or it transforms into something else entirely. The ocean is always negotiating with the ground beneath it. Every break you've ever seen, every gentle swell you've felt is the result of that conversation. The physics is simple. The beauty is in watching it play out. Subscribe to discover the hidden physics in the ordinary, from the next video to the one after that.